Hey, you guys, welcome back. Today we're going to go over the Relearn assignment for Unit 1B. This is the unit with all the fractions and decimals. So remember, if you want to retake your test or if you want to make test corrections, you have to complete this Relearn assignment entirely. It has to be all the way done before I'm going to let you do test corrections or a retake. I really want you to learn the material, and that way you can go and do your test corrections or take a retake with a ton of confidence, and you can go and do really well on it. Okay, so let's go through this. First thing is simplifying these fractions. Oh, wait, let me get the pen. There we go, perfect. Whenever we simplify fractions, we're looking for this right here, the GCF. That's the greatest common factor. So we're looking for the greatest common factor of the numerator and denominator. So here I have 5 and 10. Now, I could write out the factors for 5 and 10. The factors of 5 are 1 and 5. Those are the only numbers that go into 5. The factors of 10 are 1 and 10. And 2 and 5. Notice how I always write them in pairs like that. 1 and 10, 2 and 5. That's because 1 and 10 multiply to give me 10. 2 and 5 multiply to give me 10 as well. When I write them in pairs like that, I have a better chance of not forgetting any. It's kind of hard to write 1, then 2, then 5, and 10 and trying to think what goes into 10. This is a little easier way. So the greatest common factor here would be 5. It's the number they have in common. That's the largest number they have in common. So I'm going to go over here, divide by 5. Divide by 5, and end up with 1/2. That's it. Let's look at the next one. -2/8. Now, again, you could write out the factors if you want to, but eventually, once you get a ton of practice with this, you're eventually just going to be kind of doing it in your head, all right? Or at least getting a little better at doing it in your head. So, if we want to write them out, -2, I'm not going to do factors of -2. That negative over here is important, but I'm just going to make sure I don't forget it when I simplify it down. I'm just going to do the factors of 2. Factors of 2 are 1 and 2. Factors of 8 are 1 and 8, 2 and 4. So the greatest common factor here would be 2. So I'll divide both of these by 2. Now, look at this. I have -2 divided by 2. That gives me -1. 8 divided by 2, that gives me 4. So I simplify down to -1/4. Notice how I keep the negative in my answer when I simplify. I don't let it go. I keep it, okay? The next one, -9 and 21. Again, you could write the factors of 9 and 21, but when I think about those, what number goes into 9 and 21? I think 3 goes into there. And sometimes I may not get the greatest common factor, and that's okay. You can simplify down in steps, and that happens. That's not a problem at all. -9 and 21, I know 3 goes into both of those. I'm going to divide both by 3. -9 divided by 3 gives me -3. 21 divided by 3 gives me 7. So -3/7. And those don't have any factors that can go into them to simplify it further. So that is the simplified answer, -3/7. Let's look at this one, -3/8. Now, if you're looking at this, you're going to realize that 3 and 8, they don't have any greatest common factors. To really simplify this down and make the numbers smaller, but look, they both have a negative sign in them. Whenever we write a negative fraction, let's take this one, -3/7 that we just did as an example. If I have one negative, I can put it anywhere in the fraction that I want. I can put it with the numerator. I can put it next to the fraction bar. Sometimes that's a little tricky though because it kind of looks like just a long fraction bar if you're not really careful. So just be cautious if you do it like that, okay? But you may see it like that, so it's important you know it can be written there. So 3, 7, and then this little negative with the fraction bar. Or in the denominator, 3/-7. I'm going to put an equal sign between all of these because these are all equal to each other. You can have it anywhere you'd like. It's your preference. My preference is always in the numerator because that's just like how I learned it. That's my habit. But you can put it anywhere you'd like. Whatever your habit is, that's great. Whatever you feel most comfortable with. So let me give that an erase though. Actually, let me keep it up there. Hang on one second. So there's one negative in all these. That's really important to notice. But if I have two negatives, that's different. That's a different problem. This is not the same. So let's look at this problem that we just did. -3/-8. Now, whenever we simplify, if I have one negative, I can put it wherever I'd like. But if I have two, I'm going to get rid of both of them. So -3/-8 turns into 3/8. Now, the reason for that, technically, is that we can simplify any fraction as long as the greatest common factor is something other than 1. What if I wrote out the factors for 3 and 8? I'd get 1 and 3. I'd get 1 and 8. 2 and 4. Now, these are technically -3 and -8. So if I actually went and wrote out the factors, they'd all have a negative in front of them. Remember, we don't really think about it in this way because we know that if there are two negatives, they have to be a positive. So let me tell you why, though. If there's two negatives, technically I could factor out a negative 1. So negative 3 divided by negative 1 is positive 3. Negative 8 divided by negative 1 is positive 8. That's the real reason why I can simplify it this way, because it's not just a 1, it's a negative 1. And I can factor that out. I can get rid of that. So, all that to say, the short version of all of that is if there is one negative in your fraction, you can keep it wherever you want. If there are two, you have to get rid of both of them and make it a positive. Also, another reason is because every fraction is kind of like a division problem. This could really be negative 3 divided by negative 8. And we know our division rules for integers and negative numbers. A negative divided by a negative is a positive. So that's why we get 3 over 8. Let's look at the next one, 15 over 7. This is an improper fraction, but I want to turn it into a mixed number. So looking at this, I'm going to look and see how many times that denominator goes into the numerator. 7 goes into 15 without going over 7, 14. That's twice. That's my whole number. It goes in there twice, and that gives me 14. I'm going to see how much is left over. There's 1 left over, and I keep the denominator the same, 2 and 1/7. Look at the next one. Negative 22 over 11. 11 goes into 22. Let's see, 11, 22. Oh, twice. There's none left over, so I'm not going to have a fraction. But look, this negative, that was with the negative 22. I can't forget about it. So now this reduces down to negative 2. And as we remember, every fraction is just a division problem. So if you saw this as a division problem, it's really negative 22 divided by 11. That gives you negative 2. So that's simplifying. Let's look at the next one. So this one is 1/5 plus negative 3/5. This is all the fraction operations. The first three are all adding. So let's look at this. Whenever we add, the most important thing is this. If I add fractions, I absolutely have to have common denominators. If the denominators are not the same, I can't add them. I got to make sure they're the same first. So look at this. 1/5 plus negative 3/5. Are the denominators the same? 5 and 5, yes. So I can go ahead and add them. When I add fractions, when I have the same denominator, I keep it in my answer. The 5 stays the same. And then I just add the numerators. 1 plus negative 3. That gives me negative 2. It's a negative right there. I can't simplify it, so that's it. Negative 2/5. That's my final answer there. Let's look at the next one. Negative 1/5 plus 3/4. Do they have common denominators, a 5 and a 4? Nope. So I have to make them common. The way we do that is we look for the LCM, the lowest common multiple. Now, this always gets confused with the GCF. It's kind of like 3-letter phrases, and we use them a lot. But when I'm looking for common denominators, I'm looking for the LCM. So if I was actually to write out the multiples of 5 and the multiples of 4, it would look something like this. 1 and 5. Oh, wait. Oh, my gosh. I just made that mistake. It's so easy to make that mistake. I was trying to write the factors. Multiples sounds like multiply, meaning I'm going to make this larger number. Or this number larger. So 5, the multiples of 5 are 5, because that's 5 times 1. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20, then 25, and so on. Let's look at 4. 4 times 1 is 4. 8, 12, 16, 20. Let's see. What's the lowest number that they have in common? The least common multiple, it would be 20. So I'm going to give this an erase just so I have room in the box to write. So I found 20. That's going to be my new common denominator. So I'm going to rewrite this problem with denominators of 20. Now, I have to go back up here, and I have to go through and make sure whatever I did to the denominator to turn it into a 20, I have to do the same thing to the numerator. 5 into a 20, I did that by multiplying by 4. I'll do it up here as well. So 5 times 4 is 20. Negative 1 times 4 is negative 4. 4 into 20, well, I had to multiply by 5 to do that, so I'll do the same thing up here. 4 times 5 is 20. 3 times 5 is 15. So now, do I have common denominators? Yes, I do. So I'm going to keep the denominator. It stays the same when I add these. Now I just get to go and add the numerator. Negative 4 plus positive 15. That gives me positive 11. I can't simplify it, so that's my answer. 11 over 20. Let's look at the next one. First thing, when I add fractions, I have to make sure the denominators are common. Are they the same? 7 and 3? Nope. So I got to make them the same. I'm going to think about the lowest common multiple. Let's see, 7 and 3. I know I have 7, 14, 21. For 3, I have 3, 6, 9, 12, 15, 18, 21. Oh, I have 21. That's the lowest common multiple. So I'm going to rewrite this problem with common denominators of 21. So I turned 7 into 21 by multiplying it by 3. I'll do the same up here. Negative 4 times 3 is negative 12. I turned 3 into 21 by multiplying it by 7. I'll do the same up here. Oops. So I get negative 1 times 7 is negative 7. Now, do I have common denominators? Yes. So I can keep that in my answer, keep the denominator the same, and I'm just adding the numerators. Negative 12 plus negative 7 gives me negative 19. I can't simplify it, so that is my final answer right there. Let's look at the next one. This is subtraction. Whenever we have a subtraction problem, we always use this method right here, that keep, change, change method. So I'm going to rewrite this. Negative 1/2, I keep it the same. We don't change that. I change subtraction to addition, and I change the sign of the following number. So now this problem is negative 1/2 plus positive 8 over 11. And look, this is just an addition problem, just like the ones above. You know what? So I can just use my addition rules whenever I do this. So do I have common denominators? I need that when I add fractions. I don't right now, so I have to make them common. So let's see, 2 and 11, 11, that doesn't work because that's not an even number. Let's see, 11, 22, oh, 22, I bet that works. 22, 22. Let me rewrite the problem. So I'm going to use denominators of 22. To turn 2 into 22, I had to multiply by 11. I'll do the same thing up here. So I get negative 11 over 22. 11 into 22, I had to multiply by 2. So I'll do the same thing up here. I get 16 over 22. So are the denominators the same? Yes, they are. So I'm going to come up here, keep the denominator the same of 22, and add the numerators. Negative 11 plus 16, that gives me 5. I can't simplify it, so that's my answer. Let's look at the next one. Again, I'm going to use that keep, change, change method and rewrite it. So I keep the first number the same, negative 1/6. Negative 1/6. Subtraction becomes addition, and I change the sign of the following number. And now I can just use my adding fraction rules. Do they have the same denominator? No. So I got to make them the same denominator. 6 and 2, oh, they have a common denominator of 6. So looking at this, I don't even have to change the first fraction. It already has a denominator of 6, so I'm going to keep, if I keep the denominator the same, I keep the numerator the same. I turn 2 into 6 by multiplying by 3. Multiply by 3 up here as well. So now this one is negative 3 over 6. So the denominators are the same. I'm going to keep it in my answer. And I just add the numerators. Negative 1 plus negative 3 gives me negative 4. I can simplify this. They're both even numbers, and I know all even numbers are divisible by 2. I can use 2 as a greatest common factor. And now I get negative 4 divided by 2 gives me negative 2. 6 divided by 2 gives me 3, so I get negative 2/3. Let's look at the last one. Same process. I'm going to use that keep, change, change method. So negative 1/4, I keep it the same. Subtraction to addition, and change the sign of the following number. So now I can use my addition rules of fractions. They don't have the same denominator, but I need them to. 4 and 8, they have a common denominator of 8. Let's see, I turn 4 into 8 by multiplying it by 2. I'll do the same thing up top. I get negative 2/8. 8 into 8, hey, I didn't have to change the denominator. Great, if I don't change the denominator, I'm not changing the numerator. So that stays the same. Now, the denominators are the same. Perfect, I can add and keep that same denominator in my answer. And then just add the numerators. Negative 2 plus 3 gives me 1. So I end up with 1/8 as my final answer. I can't simplify it, so that's it. All right, now that's part 1 of this. I'm going to stop the video here, and I will pick up with you guys on part 2. All right.